Get started.
This meeting is being recorded.
Shall we start?
Yeah, Rohini, start. Good afternoon.
A very good afternoon to one and all. I, Ms. Rohini, Department of Zoology of esteemed KLE Societies, Arts and HSK Science Institute, Hubli. Karnataka Lingayat Education Society, Belagavi, was established in the year 1916 by 7 dedicated and highly educated eternal visionary founders. The seed of the education sown by these visionaries made to grow many traditional and professional institutions. Presently, our society encompasses 250 institutions. Our KLE Arts College was started in the year 1952 and Science Wing HS Kothambri was made the beginning in the year 1966. Further, in the year of 2009, a college provided post-graduation education in the mathematics. A college is accredited by NAC at A grade with 3.1 CGPA in third cycle, and we are waiting for a fourth cycle. With this brief introduction of our institute and our college, I welcome you all for this one-day national webinar, Need to Restore You All, the one-day national webinar, Need to Restore and Revive Coastal Fisheries and Livelihood by Habitat Restoration Programs, Farming and Orientation of Fisheries, Importance of Coastal Ecosystem. With these, I welcome you all. Now, I request our principal ma'am to welcome the gathering. Over to you, ma'am.
Thank you, Rohini. It's a wonderful invitation and welcome. Thank you, Rohini. I, Dr. Uma, the head of the institute, welcome all of you, and I wish on the KLE's management and our KLE societies, SK Arts and HSK Science Institute, Hubli, wishes a very happy National Science Day. Today, we are celebrating the National Science Day, and Dr. Jo K. Fizakhudan, the principal scientist, is with us, who will focus on the need to restore and revive coastal fisheries and livelihood by habitat restoration programs, farming, orientation of fishes, importance of coastal ecosystems. Without wasting much of the time, I will hand over the platform to Dr. Joe, sir. Sir, please. Hello, sir.
Yeah.
Yeah.
So, thank you, the organizers, particularly Dr. Uma, madam, and the other officials of the college. I'm glad to hear that the college has got a long, prestigious tenure. It has started as early as 1952, and it has got a PG department.
Yes.
I'm glad to hear the progress of the college and the various institutes under its umbrella. And the opportunity, I don't know how you have found out my name, and I'm sitting on the other side of the country, and somehow you have found me out, and we are delivering. I hope I'll do some justice. Once again, I wish you all a happy Science Day. And this is a day of remembrance of our Sir C.V. Raman, who discovered, or rather published his findings on the scattering of light today. And he has also got a little bit of connection to the marine science in a way. So I'll just go on to my PowerPoints.
Yes, sir.
I'll try to share the screen with you.
So just a minute, sir. Just I'll give the introduction, sir.
Okay.
Yes.
So just introduction about Sir. So Sir has completed MSc in Mariculture. He has served as a scientist in charge of the RC of CMFRI in Veravai. Sir has completed his PhD in lobster biology and reproduction in Bhavnagar University, Gujarat. Development technology for breeding and larval rearing of 2 species of marine lobsters. Sir has written 100 research articles and public papers have been published. Sir also did a poster to training manuals, and Sir was awarded as a Best Paper Award in MECOS and MEBAI International Conference. Also, Sir presented papers at MARE, Amsterdam, Cancun, Mexico, Taiwan, and Ames, Townsville, Australia. Sir's expertise in marine lobster husbandry, hatchery, and farming and conservation, Marine EIA, RIA, Gujarat Government, Tamil Nadu Government, TNFD. Sir also climate changes and studies networking. Sir presently serving as a principal for 25 years and office in charge of Kovalam Field Lab under the regional station of CMFRI at Chennai. Sir's achievements: Sir completed the breeding seed cycle for 2 marine lobster species and production of 3.5 tons of sea base in 6M IDC cage, and established mariculture lab in an aquaria in Varavale Center, established first lobster hatchery at Kovalam Field Lab, Chennai, India. Sir also entered into MOU with Cornell University, USA. With this brief introduction, I welcome you, sir, for this one-day national webinar, and over to you, sir.
Thank you so much. Thank you, Rohini.
So we can start the session now, sir?
Yeah.
Okay.
I have to select my PowerPoint. Can you see my slide?
Yes, sir.
You are able to see my slide?
It's showing started screen sharing, sir.
First slide?
No, sir.
Now? Has it come?
No, sir.
This is a problem. It's already there. Now the screen is visible?
Sir, just a minute, sir. Yes, sir. It is visible now.
Hello?
Yes, sir, it is visible.
We can see the screen.
Yes, sir.
Is it full screen now?
No, sir.
You are seeing it as only PowerPoint mode or only full screen?
So it is not in full screen mode, sir.
I have made it in full screen. Is it visible now?
Sir, it is visible, but it is not in a full screen mode, sir.
Oh.
The recording has stopped.
Now?
No, sir.
For me, it is full
So
screen.
just press F5.
F5.
Yes, sir, F5. Function key.
Okay. Yes.
No, sir, it is not working. I think we can start by itself, sir.
You can see the slides, right?
Yes, sir. Yes, it is visible, sir. We can start, sir.
Okay. So, my dear friends, faculty
This
members,
meeting is being recorded.
faculty members and students. Glad to be here with you on this day of national importance. We are celebrating the National Science Day. So we are commemorating the discovery announcement of Sir C.V. Raman, explaining the Raman effect. I'm thanking all the organizers and officers from the SK Arts College and HSK Science Institute for the invite, and to my parent organization ICAR CMFRI and my director Dr. A. Gopalakrishnan for having permitted me to give this lecture. And I come from an organization which is as old as this country. We are celebrating 75 years this year. And this was founded by some of the ancient British scientists. It was founded in Chennai in the Madras University Library, and later on it was shifted to Mandapam, and from there it got shifted to Cochin. We have stations all across our maritime states, right from Gujarat, Maharashtra, Karnataka, Kerala, Tamil Nadu, Andhra Pradesh, and Orissa and West Bengal. And these are the stations we have. We have completed 75 years of research in marine fisheries. Before that, I would like to say we work on the marine fish living resources of the oceans. We work on the fishermen communities who live in these coastal habitats, and we work on the environment and the water quality, and we work on taking the census of the fishermen. We work on the socioeconomics. We work on the climate change parameters, on the meteorology and weather, and we also work on the biotechnology and genetics part of the living resources. So there are several divisions in our organization. Our headquarters is in Cochin. I am working at Chennai Research Station, and I have a small laboratory in Chennai called the Kovalam Field Laboratory, where I have a hatchery for marine lobsters and other fishes. Whenever you have time, when you visit Chennai, you can visit my lab. Now, coming back to my subject and talk, I would like to take the students and faculty to a small area. Although it is not very small, you can see the extent or the magnitude of impact it can create on the entire ocean or entire planet. I'm talking of a zone of 200 meters on land to 200 meters into the sea. That particular stretch of area, we call it as the coastal domain, and this being the largest ecosystem on the planet. 200 meters on the land, 200 meters in the sea. So altogether, this 400-meter patch all along the coastline, we call it as the coastal ecosystem or the marine coastal ecosystem. Now, what are these significant features? 18% of the surface of the globe is only covered under this, and it can contribute to 15% of the global primary production, that is using sunlight, producing food. And 37 to 40% of the global population lives in this area. That is very important. Close to 40% of the human population is living in this area. And more than 80% of the world's fish catch, marine fish catch, is coming from this waters, not from the entire oceans. And this contributes to only 8% of the ocean and only 0.5% of the entire ocean volume. It's not a huge volume, nor it is a huge area we are talking of. And now, what are the contributions this area is making? Biological contributions. That is very important. Please note, 50% of the global denitrification, that is the entire metabolic waste from our human beings, from our anthropogenic waste, from the agriculture, from cattle, from industries, everything, all the nitrogenous waste, ammonia-based waste is getting converted in these coastal waters. 50% of the global denitrification. 80% of the organic material is buried in these waters. 80% of the entire production is buried here. 90% of the global sedimentary mineralization, that is, all the mineral deposits are taking place here, which gets demineralized at a later stage. So the cycling of nitrogen, phosphorus, potassium, iron, calcium, magnesium, zinc, copper, all these elements are getting mineralized here, demineralized here, and then recycled. So 90% of the global sink, 75 to 90% of the global sink of all the river loads, elements, and pollutants are coastal waters. Lastly, but not the least, 50% of the global carbonate, calcium carbonate, magnesium carbonate, potassium carbonate deposits are in the coastal waters. Now, there are some sub ecosystems we can see. Those are the mangroves, salt marshes, seagrass ecosystems. And these are the atmospheric carbon capture systems. They produce large amount of green, that is the green leaves, mangroves, salt marshes, and seagrasses. And therefore, they capture large quantities of carbon dioxide from the air, and they produce detritus, and that is recycled to the sediment of the coast. And this system is 5 times more than that of tropical forests. Always when we talk of greening the environment, we talk of only thinking the forest and forestation programs. But imagine the mangroves, salt marshes, and seagrasses can be 5 times more effective than the tropical forest, and therefore they are called the lungs of the sea. And they keep the carbon trapped in the ocean floor called the blue carbon. What is blue carbon? The carbon which is trapped in the sediments on the coastal ecosystem are called the blue carbon, and therefore the large quantities of carbon dioxide remain buried as a reserve. Therefore, they are also called as carbon scrubbers. So this is the significance of the coastal domain which we live, and we have to understand the significance of it. This altogether leaves us, that is, this area gives us 50% of global oxygen. That is quite a huge contribution from these waters. Now, this particular slide, I wish to express or give you an illustration how the whole cycle works. The first few meters, that is about 100 meters of the surface of the ocean, is called the euphotic zone. After that, it is the twilight zone, and further beyond 1000 meters, there is no light reaching. We call it the deep oceans. The surface oceans, due to the increase of nutrients and wave action and oxygen mixing and carbon dioxide availability, produces a lot of phytoplankton, that is the microscopic green. And the microscopic green forms the food of herbivorous zooplankton and smaller group of organisms. And those group of organisms tend to form the food of larger forms of organisms like the fish or the molluscans or the arthropods or the crustaceans and so on. So the entire cycle is supported by a primary phytoplankton or a food production in the surface waters. All these animals die at some stage. They consume and eat, and there is a metabolic waste also. So the waste and the death and decomposed detritus tend to sink to the bottom. That is a natural tendency in the open oceans. There is a huge sink taking place, and that is called the biological pump. So here the pump is going down. All the dead organic matter or the settling down plankton, phytoplankton, zooplankton, and fish are called organic matter settling down. That is called the biological pump. And all this phytoplankton releases oxygen when they are doing photosynthesis, and during the reverse in the night hours, they release carbon dioxide when they are into respiration. So there is always a possibility of exchange of gases when there is increased phytoplankton, when there is available nutrient in the water, and this is how the whole cycle maintains in the system. There are 3 important cycles you have to know: carbon and nutrient flow. Just like carbon, there is a nitrogen flow, there is a potassium flow, there is a phosphorus flow, cycle taking place in the entire oceans, continuous. Similarly, there is a microbial loop. The 70% of the ocean's biomass is constituted by viruses, bacteria, and protozoa. 70% of the ocean biomass is covered by viruses, bacteria, and protozoa, not larger, bigger fishes or whales and dolphins, never. And they tend to form a loop. They are the ones who decompose, they are the ones who recycle, they are the ones who remineralize the elements back into the system. So that is called a microbial loop that is continuously working in the oceans. Third thing is a physical mixing. Oceans are a product of several physical parameters like the lunar gravitational forces, the Earth's gravity, the circumventing forces, physical forces. Then there is the what you call temperature variations. There is wind, Then there are eddies and circles formed due to the currents of the water, and so on. So a lot of physical parameters. The tides are formed by the gravity pull of the moon and the sun and the earth, and therefore there are high tides and low tides. So the oceans are a package of dynamic systems of a lot of physical activities: tides, currents, eddies, flows, upwellings, downwellings, and you will hear so many such things. And the bottom, of course, remains untouched most of the time in the deeper areas, and they are therefore anoxic. No oxygen available in deep sea conditions, and there is no light possible there. That is a condition available in oceans. Now all this is put together. How do people live on these? In spite of all this, we say close to 40% of the human population lives in this area. What are the benefits they get out of it? A lot of interests are there. Tourism, the places are very pretty and beautiful, landscapes are very pretty, recreation possibilities are huge, consumer commercial fishing practices, as I said, 80% of the fish catches are caught here, so you get good protein. Sport fishing, subsistence fishing, traditional fishing, industries, water sources, discharge of effluents, cool weather and environment, navigation and transport, very important, shipping, navigation and transport. So all this makes this place more accessible to human beings. It is more habitable. Physical parameters are there, human interferences are there, and we are also going to contribute to pollution in large scale because we are going to discharge all our waste into these immediate waters. So it may be industrial, it may be from animal side, it may be from agriculture, it may be urban pollution, and the inborn or inherent biological parameters are like phytoplankton, zooplankton, the nutrient cycle, carbon pump, downwelling, upwelling, and the fish population, birds, marine mammals, turtles, crabs, and the immediate shoreline fauna and flora. So this is a holistic view of entire coastal ecosystem. People live there, have fun. They also exploit the situation. They pollute the environment, and this place is now tending vulnerable every year. Now coming back to the chemistry part of it, what happens normally in an air? We have carbon dioxide going into the air or oxygen going into the air during respiration or photosynthesis. But due to increased anthropogenic development, like human populations in urban cities like Mumbai, Calcutta, Chennai, we release more of carbon dioxide due to vehicular releases, due to industrial pollutions. Nitrous oxides is released more, carbon dioxide is released more, carbon monoxide is released more. We release a lot of ammoniacal waste, hospital waste, industrial waste, and agriculture waste through our rivers into the immediate coastal waters. That leads to increased nutrient level of the waters and causes eutrophication, sudden blooming of waters, producing of primary planktons in large numbers on a particular day, leading to kill of organisms and matter in one fine morning, and leading to a lot of detritus forming and anoxic conditions and fish death. Similarly, the oxygen levels get reduced because of other gases which are lighter, and their elemental status removes a lot of other molecular fractions. And then finally, you have an acidic atmospheric condition, like you have nitrous oxide or nitric oxide in the air, more of carbonic acid in the air, causing acid rains, thus leading to reduction in pH of the coastal waters and the oceanic waters. Similarly, we have more of ozone in the atmosphere, causing more of ultraviolet coming into the ocean waters. Again, ultraviolet is inviting more of phytoplankton. Sudden blooms create an oxygen deficiency, because there is a large bloom leads to large deaths, and that causes again deoxygenated or dead zones or oxygen minimum zones, causing an anamox condition in the oceans. And these are some of the chemical reactions which is now leading us into an increased temperature scenario, or an increased or a what you call acidic water kind of scenario in the oceans. We say ocean is tending to become more and more acidic. It is, the temperatures are increasing in our coastal waters, and in 50 years time some certain drastic changes are going to take place. Now what's there in our waters, in our oceans? There are about 2 lakh species which has been documented, and 2 million species are yet to be documented in marine conditions. And the sizes are from as small as 0.01 microns to about 33 meters. That is a blue whale. And the organisms, as I mentioned, 70 to 90% of the ocean biomass is constituted by nothing other than the viruses and bacteria. And the rest is only contributed by the so-called planktons and fishes and crabs and shrimps and all sorts of things. The study of this particular marine life, we all know it's marine biology and biological oceanography. And the term Latin mare is the origin for sea or oceans. Coming to the Indian context, we have roughly 13,000 species. And out of it, 99% of the microbes we are still not identified, just identified with 1% of the microbes. And India is one of the recognized 12 mega biodiversity countries and is also one of the 25 hotspots in the world. It has got an estimated 2.02 million square kilometers as the exclusive economic zone, or it has also got 21,780 square kilometers of continental shelf. That is the immediate coastal waters of India. What are the species we have? Diatoms. They are microscopic small phytoplankton made out of silicaceous cells. There are about 200 species. Algae 844, seagrasses 14, mangrove trees and shrubs 39 species, porifera, that is the sponges, huge group, that is 486 plus. Cnidarians, that is the corals and polyps and jellies, about 842 species. Polychaetes, there are the worms, 250 odd species. Brachyurans, 705. Molluscans, 3,370. The starfishes and sea cucumbers community, the echinoderms, 765. The vertebrate fishes, 2,546. And as I mentioned earlier, sponges, 450 plus, corals, 280. Just to give you a few examples, under the microscope, how does this phytoplankton or the diatom look like? What are their sizes? How much of diversity is there? What are the shapes and how much of color variations they use? And when it comes to color, again, I wanted to tell you, Dr. Sri C.V. Raman, Sir Sri C.V. Raman described, and he debated the earlier theory of Dr. Raleigh. Earlier, Raleigh's theory on the blue color of the ocean was established in 1901, but later on, it was Sir C.V. Raman who established the fact that the scatter of light of the blue color of the oceans is due to a particular absorption of a particular wavelength of the light. The longer wavelengths get reflected rather than getting absorbed, and it is only the blue light or the blue wavelength which gets more absorbed into the waters. Therefore, we have oceans which are blue in color. So today's day is remarkable in that way that we are remembering a Nobel physicist, a Nobel laureate from the physics from our country. With all salutations to him. And I wish to again record certain things, like the water also changes its color because of these small organisms. Like sometimes the water tends to be reddish in color, sometimes the water tends to be yellowish in color, golden in color, because of these microscopic organisms blooming in millions and millions per ml. Subsequently, what groups come up is the zooplankton. They feed on the small phytoplankton and they grow. Most of them are smaller ones. They don't grow big. So they are called the planktons. But there are some which are the babies of the larger ones. So they are called the juveniles or the larval stages or the post-larval stages, or we call them the babies or fries. So that can include the zoea, protozoa, the phylosoma, the fish egg and embryo, and so on.
Sir, your screen is not moving, sir. Only the first slide is seeing.
Oh God. Can you see the slide?
Yes, sir. Now it is seen.
Second slide.
What, sir? Hello.
Can you see the second slide? CV Raman sir photo?
Slide. It's a slide number they have not mentioned. Coastal domain. This is the slide I am getting, sir.
Coastal domain
200 meter
coastal
on
domain is
land.
the fourth slide.
Okay. That slide I'm getting, sir.
How is it different? Like I am presenting something else, it is coming coastal domain. So this I have already discussed. Coastal domain I have already discussed. Now do you get the second slide?
No, sir.
There is something else going wrong.
The slide is not moving, sir.
Can you see the slide?
It is first slide, sir.
Yeah.
Okay. Now you can move the slide, sir.
Second slide.
No, sir. It is not changing.
That's very strange. Even now it is not come.
No, sir. Still it is in first slide only.
In my presentation it is coming. I'm sharing. Is there any other mechanism to do it?
Just try once again F5, sir. Slideshow. Go to the command that slideshow, sir.
Yeah.
Yes. You have stopped sharing, sir.
Should I share it from window or the entire screen?
Sir, just share once
Hello?
again. Sir, share the slide, sir. Now you have stopped sharing the slide.
I have stopped sharing.
Once again, press the command share screen, sir.
Yeah. Should I share from the window or the entire screen?
Share the screen, sir. Share the screen option.
Yeah, there are two options, entire screen or window.
After pressing share the screen, select a window, sir.
Yeah, they have selected
And
the
you will
window.
be able to get a PPT.
Yes, now the PPT is open.
Okay. Now it is seeing second slide, sir. I'm getting second slide.
Okay, and further it is not moving, no?
Yes, sir. Just press down arrow key, sir.
Yeah, down arrow I pressed.
But it is not moving, sir. So better
Now?
go to, yes, sir. Now it is moving, sir. Third slide.
Okay, this is the third slide. So I need not go again through the slides, perhaps. I've already discussed these points.
It's okay, it's okay.
Now you can see the fourth slide, coastal domain.
Yes,
This I already described. What is the importance, how it produces 50% of global oxygen. Am I okay with this?
yes, sir. You can continue, sir, now. It's 50 slide.
And this also I have explained regarding the cycling carbon and nutrient flow, microbial loop, and the physical mixing in the ocean waters.
Sure.
Okay. Yeah.
Okay, sir.
And this was the slide where I mentioned how the livelihood is impacted on a coastal waters and how the whole system of physical activity, our contribution to the immediate environment takes place in the coastal waters. This is where I described on the chemical part of it, the load of nitrous oxide, nitric oxide, ozone, and oxygen, and how acid rains are formed, leading to increase in temperature and oxygen dead zones. Okay?
Yes, sir.
Yeah. And this is what I mentioned about the number of species available in Indian waters and globally. And then I came to this slide where I mentioned about the variety of phytoplankton and diatoms and how they play an important role in the productivity and the color of the water. And I mentioned about Sir C.V. Raman's input on how the ocean color is blue. I stopped here. Okay.
Okay, you
Hello.
can continue, sir.
Yeah. And these are the zooplanktons which I was mentioning, the secondary level consumers, and some of it are also essentially the babies of fishes and crustaceans and the commercial varieties of fishing groups. Then again, another important one which often most of our biologists and academics tend to forget is our coastal waters have huge quantities of sediment, the beach sediments or the under the seabed sediments, and they harbor thousands and thousands of organisms in those soil, which are the efficient engineers. We call them as the marine sediment engineers, and they work on day in and day out without any holiday, converting all our organic carbon, organic nitrogen, organic phosphorus, organic potassium, everything into a demineralized or a detoxified state back to the waters. And these engineers are in each stage, they are converting each process, each metabolic activity is taken up by one group. So even if one group fails, we are having a problem with respect to a particular end product. So there are thousands of these kind of worms, polychaete worms, annelid worms, the gastropods and the pelecypods, filter feeders, and so many things. They do this conversion. And this again is very highly densely populated in this coastal domain, not in the deep sea. It is only higher in the coastal domain because that is where this intensity of all these pollutants accumulate. And they are the converters. They are the life givers of this planet. One day they strike, the entire ocean comes dead, and the recycling of carbon, oxygen, everything goes to a full stop. Planet life will be in a big question mark. People don't understand the seriousness behind it. And these are some of the coral reef associated organisms, which we don't notice: barnacles, the anemones, smaller shrimps and crabs, then the ascidians, then the gorgonids, sea lilies, the sponges, oysters, corals again. Again, the very important smaller organisms and worms. What I mean to also stress here is when we talk about the pollution, the smaller particles of plastics and other thing also gets taken away by these groups, and they settle down when they die, and that's how we are also accumulating plastics in our organic sediment. So that is again which we are not noticing, but because of these poor creatures not able to identify nanoplastics, they are swallowing them and they are taking them to the sediments. So this is also happening in our environment. This is just to show a slide where a healthy flea in the water looks like. Again, there are a variety of reef organisms which do this recycling processes and help us in filtering of our immediate coastal waters, which we go unnoticed. Some of them are very precious. For example, this one is the pearl oyster. These are the edible oysters. These are seaweeds. These are sponges and ascidians. These are pectins. The shells are very, very precious. These are some of the fouling organisms: sea urchins, green mussels, barnacles and oysters, green mussels. Some of them are edible. Some of them are commercial valued ornaments. Some of them are excellent phytochemicals which are used for extraction of drugs from the sea and so on. But they are essential in the aquatic systems. They are converters, they are recyclers, they are transformers of the water. They filter waters to large extent every day continuously for us. And again, the significance of marine mammals. They are also called as the marine stewards or the engineers. They are not the sediment engineers, but they are generally the marine engineers. Now they are the top predators. The ocean has got kings, and the kings are the dolphins and the giant sharks. And now what do? We have seen the biological pump taking down the carbon and the organic matter down into the bottom of the sea and the oceans. And how does this thing come back to the surface, or how is it getting recycled? The only way possible is either you should have a big current of water bringing them up, or each whale can do the job of a big river. So one river can bring a large quantity of nutrient into an ocean, one whale can bring back this nutrient which is at the bottom of the sea back to the surface of the ocean. So they are also called the whale pumps. The biological pump goes down, the whale pump goes up. And each whale, after consuming tons and tons of phytoplankton, can release the metabolic waste again back to the waters that can contribute to large quantities of fecal matter and urine, and that again can fertilize the surface waters. So the whales are contributors for nutrient element. They are contributing for churning of the bottom oceans, and they are actually the Manthan group or the engineers of the entire ocean. So even though they are very less in numbers, the significance is quite huge. One whale is equivalent to one huge river which can downpour into an estuary. The organisms which live on reefs, and some of them are all babies and young ones of the larger fishes which the seafood or the exports takes place, like some of the species which I have shown here. Now most of these species, if they are dissected and studied, we understand they ingest thousands of nanoparticles of plastics. So I'll show you one particular graph and a table where the level of microplastic in the outside water is the same as the number of plastics inside the fish gut. So we are almost contaminating the fish with the level of nanoplastics, and we are consuming them unknowingly. Now, Indian coast, we say marine coast is not just one uniform marine coast. It has got close to 21 zones, and they are all different in many aspects. Just the tide or the sediment or the water chemistry or the water temperatures, exposure, currents, and so on. So they are not uniform, and you cannot have one zone, one yardstick or one rule applied to the entire coastline. So it has to be region specific, state specific, zone specific. So the management is not very simple. This is just to give you a glimpse of what is happening in Indian marine fishery scenario. A lot of fishing activities take place, and we are close to producing 3.56 million tons of fish per annum. This was the last few years production, and a lot of boats are involved into fishing. A lot of livelihoods are involved into fishing. Lakhs and lakhs of fishermen who are staying in the coastal waters are doing this activity. That is their sustenance and livelihood. And a lot of intensification is there because we earn a lot of revenue out of these exports. Now, what has happened to marine fisheries in the recent 40 or 50 years? Like when earlier fishing methods were introduced, there used to be fishing, but that was not very intensified, never industrialized. Once we started giving them more technologies, more incentivizing, and more of exports started coming in, we started capturing more and more. And we also started polluting more and more. So whatever fish now we see is a percentage of what used to exist much before. And you can see the last picture where only more of jellyfishes and unwanted things are there, and the pollution is very high. Number of nets have increased. So the coastal resources are declining. There are certain management measures implemented by various governments because of our R&D inputs, and these are some of the findings. And they say smaller fishermen can fish in the nearby waters, and the larger fishermen can go deeper waters, and the various states have their own rules to show that. Similarly, the wildlife has said some species are already extinct, some are already threatened, so we should not catch them or release them back when they are caught. And these are the species listed under the Protected Act, and therefore capture of these select species is not permitted, or they are criminal. Like the sharks and rays, some of these whale sharks. And what is the global status? The UN General Assembly says if we don't manage the fish stocks, we need to do an immediate action on it. Otherwise, only 50 years is left for the sea for fishing. And we have already exploited close to 50%. So there will be virtually nothing left to fish from the seas by the middle of the century if the current trends continue. This is what the world over scientists are telling. And why has this happened? Because in most of you know that capturing fish or going into sea is a common property. So it becomes a society's portfolio rather than an individual's responsibility. If I say there is a gold merchant sitting in Chennai or in Karnataka or Bangalore, Nobody can just walk into the gold merchant's shop and then just take away some things. But it is not. It is not like that in the open ocean. Like any fisherman can go, try his luck, catch the fish, any quantity, and bring back. So it's a common property, common access. Anybody can do, and therefore there is a tragedy of the commons. The tragedy of the commons is who will manage it. There is no incentive for management. Like if I don't catch that fish, somebody else will catch. So it is not a single man's property. Therefore, there is a increased competition, and that is leading to over exploitation of these resources. And what are the issues we are facing? Climate change and vulnerability. It is affecting these organisms also. I'll discuss how it is happening. Declining marine fish resources. I already mentioned what is happening to declining marine fish because of excessive captures and pollution and parameters of migration. Marine pollution is increasing. Increasing seafood demand. We are eating more and we need more for exports. And livelihood is also a problem. Now, just to give you a small break lighting, I am just introducing you some common species in our waters. The threadfin breams, the crocus, Otolithus jonius, Cathala, Penaya, Panna, Otolithus, several genus you will find in different states. And then again the Otolithoides group. Silver bellies, the different varieties which are in Tamil Nadu, this is very famous, called the Karappudi. Then goat fishes, which has got a typical barb at its mouth end. Rock cods, which are more native to the rocks and reefs of our coastal waters. Snappers, again reef fishes. Pig-faced breams, again reef and bottom-dwelling fishes. Pomfrets, which are very famous in Karnataka, Bombay, Goa, and Gujarat. Lizard fishes, tumbili yes. The mullets, which are estuarine, they are euryhaline groups. They are common to estuary, barmouths, and coastal waters. And these are age-old fishes right from the days of Bible or Egypt or Israel. You can find mullets existed and the fishing existed for these groups. And they say Jesus was eating this fish during his period in Babylon and Egypt. Catfishes, which is now becoming what do you call a rare variety because of its breeding problems. Threadfins, again going into rare community because it is being excessively caught. This is again a famous fish in Karnataka. White fishes used to be good and popular, but nowadays declining very fast. Flatfishes, again a prehistoric community, which is a vertebrate fish with a lot of evolutionary properties and behavioral adaptations. It is a camouflaging fish. It is a flat fish. When the larvae is born, it looks like a normal fish, but then later the morphometry changes and it becomes flat. The cranium becomes compressed. One side of the body is white. The other side of the body takes on the color of the sediment, and it is a camouflage. And it is one of the very primitive vertebrate fishes existing in our waters, and they are quite vulnerable in the recent climatic conditions. Just to give you an example of what is happening in our coastal waters, 1976 to 85, the orange map, you can see it is increasing. Every 10 years, if we see, the orange areas have increased and increased and increased. In about 20 years' time, 1 degree surface temperature of the oceans have increased. In another 50 years, we are expecting another 1.5 to 2 degrees rise. This is just to give an example of the hotspots, particularly when it comes to only in Tamil Nadu. Say in Tamil Nadu, we have 3 or 4 critical marine habitats. That is the Pulicat, then the Pichavaram mangroves, the Muthupad lagoon, coral reefs, and seagrass beds of Gulf of Mannar and Park Bay. So every state has got its own critical habitats. Like in Karnataka, you have the Netrani or the Zoari and so on. So you have a lot of critical habitats specific to each state, and the state has to look into the management. This is what I was explaining about Tamil Nadu, like Pichavaram, Pulicat, Muthupet, Gulf of Mannar, Park Bay. Then Sri Lanka is adjoining, so you have a transboundary issue there. And corals and seabed, seagrass is an ecosystem available in Tamil Nadu waters, and so on. What is happening to marine fishery scenario? Of course, the production is going up. Certain things we see as the smaller sardine catch is going up, and it is moving from Kerala, Karnataka to Tamil Nadu because they say there is a shift in temperature, and the temperature is causing an increased movement of fish from Kerala to Tamil Nadu. So this sort of phenological changes are taking place in the coastal fish as well as the resources. And that is affecting our production as well as the livelihoods. This is what I was mentioning. The sea surface temperature has gone up by more than a degree in just 100 years from 1906 to 2014. And from there, it is going to increase another 2 degrees by 2099. The surface rainfall has increased and the chlorophyll content is not substantially increasing accordingly. And this is about the COP, that is Conference of Parties on Climate Change. India is doing quite well with respect to the activities in controlling the climate change impacts, but we are still to go a long way. Rise in sea surface temperatures. You see, 0.3% on the west coast and 0.4 degrees Celsius on the southeast coast has increased. And Northern Indian Ocean has been recognized as one of the 17 hotspots of climate change in the world oceans. Sea level is to rise by 90 to 30 centimeters by 2050 and by 30 to 90 centimeters by 2100. And mostly the Ganges Delta belt as well as the Maldives will be in trouble. And in Kerala, already several coastal districts are affected by sea erosion, and half the length of coastal Kerala is protected by sea walls. You can already see that. And this is going to be very critical, particularly when it comes to acidic conditions of the ocean. Now, in the last 250 years, the concentration of hydrogen ions in the seawater has increased by 30%, equating to a fall in pH by 0.1 units. And this is going to increase. The atmospheric carbon dioxide levels are going to increase. pH reduction is expected further by 0.4 to 0.5 by 2100. This is going to kill all the diatoms and all the shell-based organisms, particularly the molluscan larvae, and it is going to create a huge impact in the biodiversity. Certain things which we have noticed, like shift in catfish movement, shift in oil sardine and Indian mackerel movement, shift in the Indian mackerel depth occurrence, and the spawning months of particular threadfin bream has shifted from 1 month to another month. So these are certain things already we are seeing in the fish stocks of our immediate coastal waters. This is just an example. This particular rat, bramble K mosaic tail rat in Australia, has already become extinct because of the 1 degree rise in fisheries, in temperature, in the surface water temperature. That area which it was living has got inundated, and this rat has no habitat, and they have lost ground. They have become extinct. So several such species are nowadays going to go under the water. These are 2 water bodies or the bar mouths existing along the Chennai coast. I am just giving you an example how a bar mouth can impact and what is this coastal domain I am talking about. A river discharge, then the urban waste getting into it, then the whole pollution of the industry coming into it, and then the water gets discharged into the coastal waters. Immediately they are mixing with the ocean waters. And these are the zones which get easily choked up, and the high density sediment engineers are under tremendous pressure. Again, another example of a drainage and effluent system close to the bar mouth in Chennai. Now, again, a very important thing is how much we discard into the oceans and how we look at these places as our sink. Because we didn't know, or we don't know the value of these coastal waters, we tend to dump everything, virtually every dust and the particle into that area, and then finally it gets into a sink. Now you see the quantity of plastics which is covering these areas, nanoparticles. Just a brief on what is happening to the plastics. Every plastic which we are using, it starts degrading only after 700 years. And this will degrade fully only by 1000 years. That means all the plastic so far we have produced from the date of first production is still not degraded completely. It is still not even started degrading. And that means it is still lying here. So all the day when we are producing plastics, it is going to only accumulate on the planet. It is not degrading. Now, the toxic chemicals which leach out of plastic are found in the blood and tissue of nearly all the marine organisms. And that is coming back to us. It may lead a lot of birth defects. It can cause cancers. It can impair your immunity, and it can disrupt your endocrine systems and hormonal functions. There is this bisphenol A, which is the PPA, which is a byproduct or which is leached out from our plastic bottles particularly. And that can even alter your hormonal levels of small children. and it's already happening, and it is almost similar to the estrogen found in young women. Then only 9% of all the plastics ever produced so far has been recycled by us. What happens to the plastics? We normally tend to throw away, or they discarded, they get through the wind or through the waters, get back into the estuaries, to the bar mouth, and go into the coastal domain. And they tend to float, they tend to disintegrate because of the UV or the wave action or the physical action, or some of it because of accumulation of dirt and microbes and bacteria, they tend to settle down. So they also occupy a large space of the sediment. They occupy a large space of the bacteria and microbes of the sediment. They contaminate the bacteria, they contaminate the smaller organisms, the poor organisms, which cannot distinguish from food, from detritus. They start consuming these nanoparticles, they die, they accumulate in their bodies, and they tend to grow, or they tend to deliver it as food to the higher organisms. And we are trying to get back plastics into our food system. We are getting more of plastics into the organic reserves, and thus blocking all the remineralization or the nitrogen or the carbon recycling processes. And therefore, it is also going to affect our oxygen supply back to the system. So these are nanoparticles and microparticles. Something close to 5 mm or less than 5 mm, we call it as microparticles. Less than that, 1 mm or something, we call it as nanoparticles. And the whole world is now full of plastic nanoparticles. Something has to be done very fast. This is what I am mentioning. And already 619 marine species studied has been impacted by plastic debris. And we are talking of most of the larger marine organisms. Even the tiny anchovies, which is caught in Japanese Bay, they found 80% of it had microplastic in their guts. This is that graph I was mentioning. When they sample the fish and the water, it is not much different. What is the quantity or the level of plastics in the water? Almost the same level of plastic was found inside the fish, whether it is in muscle or it is in tissue or it is in the blood and so on. These are some of the visceral examples. In fact, 1 or 2 are my own dissections. You can find plastics inside the stomach of fishes and birds and mammals. These are some of the sediment engineers unable to identify between the shell or the sand, and they also start absorbing plastic into their system, which is arresting their metabolic processes, and thus our engineering process of the sediment is also hugely impacted because of microplastics and other pollutants. Now, CMFRA and I have been involved into rebuilding of coastal habitats. We are creating more of artificial habitats such that more of fish, more of sedimentary organisms can tend to accumulate, and they can rebuild, they can revive in that habitat and restore some of the lost diversity. And close to 100 such sites have been built by CMFRA in Tamil Nadu alone in the last 10 years. I'll show you some of the videos. I hope I should run through my slides again. These are some of the sites in Tamil Nadu where I have deployed artificial reefs for habitat reconstruction programs, where corals, ornamental fishes, large sponge colonies, gorgonids, all this will multiply and settle down, and other fishing activities cannot obstruct them. These are some of the sites which we have deployed the artificial reefs under the seabed. Now our role, I'm coming to the last slide. As youngsters and as academics, our roles should be to reduce your use of single-use plastics, avoid glitter and face masks and sunscreens and festival makeups, wash synthetic clothing like polyester, acrylic and fleece and plastic fibers, reuse most of the things, recycle properly, opt for natural fibers, wash less, participate or organize a beach, river or a river cleanup. Especially the boats and fishermen should be encouraged to collect more of plastics and deliver back to recycling facilities. Support bans, complete bans, not partial bans. Avoid products containing microbeads and spread the word. Support organizations who are working on these lines, and it should be always positive, assertive, sustainability actions. So we have to instill, involve, initiate, invite, invoke, and inspire. Impress our children to participate in safe disposal, minimum waste, maximum utility, concern for the rest and environment. By these words, I come to the concluding two slides where the pictures or the posters are prepared by small children concerned about the oceans and the environment. This was one small girl, another one, a small cycle where oceans, we need to move these oceans and keep all these organisms alive so that the flowers bloom ahead of us. With this, I take you back to the videos. Just give me a few minutes. Is it okay?
Rohini ma?
Yes, sir.
Tamil Nadu is enriched.
Can you
with
see this?
brackish water
No,
and
sir.
fishery resources amenable
Hello?
for capture and
No, sir,
culture
it
of
is not there.
fisheries. Substantial
Can you see it?
No, sir.
Audio is getting.
dimensions of fishery resources.
Only
You're not able to see
It's
the.
not
You're not
visible,
able to see
sir.
the video. Huh?
It's not
Only-
visible, sir.
Not visible.
Tamil Nadu is enriched with marine, brackish water.
Yes.
Tamil Nadu is
Can you see
enriched
it?
with marine,
Yes, sir.
brackish water
How
and
to see it now?
fishery resources amenable for capture
No,
and
sir.
culture of fisheries. Substantial focus is being given on the economic
Can
and
you see?
social dimensions of
No, sir,
fisheries.
not
Here
visible, sir.
only,
Just
sir.
the audio is coming.
Actually, only the file is getting. We're not able to getting that video, sir.
Tamil Nadu is enriched with marine, brackish water.
Can you see now?
Sir, it is not changing. And then they will get an advanced answer. In the top center, sir, you get an advanced option. Click on that and then share the video, sir. Press share screen, sir.
Yeah.
Hello. Okay.
Yes.
After pressing share screen, there you will
Yeah.
get three options: basic, advanced. Click on advanced, sir.
I'm getting three options: entire screen, window, or Microsoft Edge.
Sir, you have three options: basic, advanced, files. Top, sir. Top center.
I don't get that.
Option is there, sir. Actually.
Sir, hello.
Yes.
There are three options: basic, advanced, and files. When you will click the share screen,
Yes. I get three other options: entire screen, window, or Microsoft Edge tab.
no, entire screen you click, and after that, there are the three options: basic, advanced, and files.
I don't get those options.
Okay, sir. Can you mail these links to me so as to
Yeah.
I can share with my students and participants?
Tamil Nadu is enriched with
Can you see it now?
brackish
No.
water.
Now it's visible.
Fishery
Now it's
resources
visible.
available for capture and
It is
farming
visible.
fisheries.
It's visible.
Substantial focus is being given on the economic and social dimensions of fishery resources by the government of Tamil Nadu. The Honorable Minister for Fisheries has made announcement in the floor of Assembly during the budget demand for the year 2019 to 2020 that the artificial reefs will be deployed in the shallow depths of coastline in Chennai, Tiruvallur and Singalputtu districts to improve the shallow water fishing. The government of Tamil Nadu for providing artificial reefs in 30 locations all along the inshore waters of Chennai, Tiruvallur and Singalputtu districts at an estimated amount of rupees 10 crores. Fisheries Minister DJ Yakumar flagged off and personally supervised the deployment of 200 units of artificial reefs over 3 nautical miles off the Arur fishing village in Besant Nagar. The idea is to revive traditional fishing grounds of small fishermen and create a cluster of artificial reefs, which act as natural breakwaters by reducing wave energy along the coast with the focus on fragile coastal stretches as Tamil Nadu is experiencing increasing recurrence of extreme weather events and erosion of beaches. There are many types of artificial reef modules available to improve the fishing and marine-related cultures. The proven result-oriented artificial reefs such as grouper modules, triangular modules, and well-ring modules. Triangular module is in triangle shape in plan, having size of the face is 1.2 meter by 1.2 meter. There is a square shape opening of size 0.15 meter diameter around the center opening, enabling the easy entry of fishes. The thickness of the slab is 0.075 meter. Grouper module is grouping of 3 circular slabs intersecting each other and placed at 120 degrees from one to another. The outer diameter of each circular slab is 1 meter and having thickness of 0.075 meter. The depth slab is 0.45 meter. The grouper module looks like flower having 7 openings, enabling the easy entry of fishes. Well-ring module is a circular ring of 0.55 meter outer diameter, having 1 meter long. The thickness of circular ring is 0.75 meter. The opening ring itself enable the easy entry of fishes. Stucco plastering is proposed on the outer face of all 3 reefs to be more convenient for forming of the algae and other fauna etc. These slabs will be casted and tied using HDPE rope of 20 mm thick. The fisheries director said the deployment activity would continue till the end of this month to cover all the 30 sites provided if the weather cooperates. Each day, about 200 units would be dumped into the sea weighing close to 150 tons. As soon as the units are being fabricated and matured over a period of 3 months, the units are transported via a small cargo vessel, and they are deployed at the respective sites, in consultation with the fishermen and their presence, and lowered to the sea bottom using divers and then launched in these specific modules as the fishermen can get the benefits out of it.
And I am very thankful to the government of Tamil Nadu and the Department of Fisheries that they are coming forward in a very huge way in funding and promoting traditional artisanal fishing, which is more sustainable. And I think that's a way forward for the entire world fisheries to come.
ஒரு 7 நாட்கள் முன்னாடி அந்த செயற்கை பவள பாறையை கடல்ல நாங்க அமைச்சிருக்கோம். நாங்க எல்லாமே ஊர் மக்கள் எல்லாம்
You're able to see these slides? Hello?
Yes, sir.
Hello, sir.
Yes, sir.
Yes, sir.
These are some of our reef sites.
Yes, sir.
Artificial reefs, after developing into a full-fledged reef, you can see millions of fish gathering in the reefs.
Yes, sir. You have worked a lot, sir.
These are our reefs, and this is a small video on livelihoods for fishermen
Okay.
for cage farms. This is my office in the beach, Kovalam Field Laboratory. These are some cages where the fishermen boys are assembling and making an anchor. And once the anchor is being made, the cages will be tied, fishes will be stocked in the sea, and they are farming. Very soon you will see the cages being taken into the sea for farming.
So, lot of opportunities are there in this field also, sir.
Yeah. You can see the cage.
Yeah.
This will be the cage which will be floating in the ocean waters. And you will stock the fish seed inside, grow them for 6 to 8 months, and then it will be marketed.
So, all the 365 days it will be there, sir? Or
It's for 8 to 9 months.
some breeding season is there?
Because 2 to 3 months we will have the cyclone and bad weather during monsoon.
Okay.
That time we will bring it back.
Yeah.
So this is a floating cage using GI pipes and 6-meter diameter and barrels. And that yellow cage is the gabion.
Yes,
The
sir.
stones will be filled inside, and that will serve as an anchor. And once the anchor is fixed, the cage will be always floating around the anchor. It is by self-weight, the cages will be fixed. Now this is a 6-meter cage where, depending on the species, from 1,000 to 3,000 numbers can be stocked.
Okay.
And after a duration, you can harvest. So this video takes a complete picture of the whole thing, right from installation, stocking, farming, harvesting, and marketing. All this is shown in this video. Now you can see the number of cages in the sea. We have a multitude of cages, close to 20 numbers.
So, how you will monitor, sir, this one?
Every day for feeding and water quality check, we have to go. This is the babies which are taken to the cages for farming.
Yeah.
The species which is being taken is cobia, Rachicentron canadum. It grows very fast. In 8 months, it can grow up to 3 kg. Now we are taken it to the cage in barrels. and now they are being shifted to the cage open waters. This is cobia fingerlings. It is being stopped. So these are fishermen boys who are being trained into a new livelihood option on the coastal waters, so that the intensification in fishing can be reduced, but their livelihood with respect to the coastal waters can be still maintained, and it can be more of a farming practice than of a hunting practice. You can see the cobia has grown, and the subsequent months again feeding will be shown. It grows into bigger sizes. It grows to about 3 kg in 8 months time. Now we are going for feeding. The sizes will be bigger. It has grown. It has come to about 200 grams. Again, in a subsequent process, we'll see how it has grown to full sizes. You can see how they have grown. Now they're going to do the feeding. How they come and sold for feeding. You can see that.
Stop, I think, sir. No.
The subsequent slides will be showing you how the harvest is taking place. Underwater videos of fully grown cobia.
So lifespan changes, sir, here outside that cage and inside the cage like that?
No. It is almost the same. The growth rates are almost the same.
Okay.
But our economical farming is only for 8 months. Beyond that, the climate time and the weather will not allow us to retain the cage there. Yeah. So we harvest after that time. Now the officials have come, they are inspecting, measuring, and then the harvest is being done. Here you can see the Joint Director of Fisheries, Deputy Directors of Fisheries, Commissioner of Fisheries. The boys are harvesting the fishes, which are about 3 kg in sizes. You can see the fish.
Market demand from this, sir, for
The final harvest is being graded by the seafood trader. All the youth members who have been trained under the program can be seen here. This is in front of our office. Yes, madam. I think I occupied a lot of your time. I hope
No.
I could compress. Yeah, please, ma'am. I think that should
No,
be
sir.
enough. Are
Actually,
there any queries from your students or your faculty? I am ready to explain. Any questions from your side?
Anyone have any queries?
Yeah. Students are all silent. Nobody wants to react. Uh-huh. It would have been nice if I had come there offline and then visited your place and given you a talk, because that would
No,
be
we
more.
will find, sir, but you have to visit our campus.
Yeah, sure.
And we are little far away from the seashore.
I can come
So
to your
next time,
place sometime. Yeah, please.
please try to visit Hubli. It is a junction place.
I have never been there in Hubli.
Of the case management as well as from staff and students.
Thank you, ma'am. Thank you very much.
Shall we end, ma'am?
One question is there, sir.
Tell me, ma'am.
One question.
Yeah. Question. We can use cage culture in pond or a lake as such good results.
We can do it in reservoirs. We are doing it, but not in lake and ponds where the water depth is very shallow. Cage is normally used where high densities are stocked, so the metabolic releases are quite huge. So it is always preferable in open running water systems rather than in closed and stagnant facilities where the densities will be again restricted. So as I mentioned, 3.5 tons in one cage. That 3.5 tons in a pond, if you take, it must be close to 2 acres. Even 2 acres, you cannot grow 3.5 tons of sea bass. To grow that, I just use the space of a small room, which is about 6 meter by 6 meter, a small room, 3.5 tons. It is possible in open waters. It is possible in reservoirs with sufficient water flow. But in ponds and lakes, as it is, we can use them because water is going to be a constraint for us. Yes.
Thank you, sir. Any other questions? So cage is the only one system we can use, or any other methods?
There are other things like pen systems are there, cage facilities are there. Then you have racks and rafts being cultured for oysters and mussels, lining systems for seaweeds. I did not go into all those details because you are not familiar, I understood, from the marine side. So I think you need an exposure on those sides because that's an elaborate subject. What I wanted to brief was the importance of coastal domain into our livelihoods, how these systems are breathing for us every day. And if we don't attend to their immediate problems, we are all going to be in trouble very soon because they are our recyclers. They are taking our cushion too long a time, and they should be done something very fast. They are productive waters. They give us food. For centuries, they have been providing us seafood. And it is not the deep sea which is giving us seafood. It is this coastal domain which is giving us seafood. So we have to be careful of using them, dumping our waste, etc. Yes. You have a zoology department there, PG?
Yes, sir.
No, not PG. Not PG, sir. UG is there.
UG.
Yes.
And in very short time, are you planning for a PG there? No.
Yeah, we are planning, sir. We are planning.
Okay.
Yeah.
Very nice, very nice.
Thank you.
All the best. Thank you once again, madam, for inviting me. I don't know how you got into me, but I'm very happy to associate with the academics and universities. I do take classes. Yeah.
Thank you.
Thank you very much.
Thank you. Thank you so much, sir. Thank you. Rohini, go ahead.
Shall we have a group photo?
Before that, just
on their videos.
Stop sharing, click money. Sir, just press on that stop share, sir.
Yes.
Okay, sir. Thank you. So now we request all the participants to switch on their video so that we can take a screenshot. Dear participants, please switch on your video. We will going to take a screenshot.
Okay. Have you done?
Yes, sir. Yes.
Okay.
You can pass my contacts to some of the students. I think
Yeah,
some
yeah.
have asked on the
Yeah,
phone call.
participants are asking, sir. Sir, sure, we
Yeah.
will send.
Yeah, please.
I think Rahul has asked. So we will send the contact details of you. Thank you,
Sure.
sir. Thank you spending your quality time on National Science Day and making this Science Day a wonderful one. Thank you, sir.
Thank you,
sir.
ma'am. Thank you very much. Thank you for the opportunity. All the best for all the students and faculty members.
Thank you.
Thank you once again.
And shall we have a vote of thanks?
Yeah, yeah.
Firstly, I would like to thank our resource person, Dr. Joe Kizahuddin, who spent his valuable time and explained regarding us about the fisheries, the fish production, and the role of plastics and ban of plastics. I also extend
Rohini. Rohini.
Firstly, I would like to thank our resource person, Joe Kizokudin, who spent his valuable time and explained us regarding the coastal domain and also about the coral reef importance and the significance of fish production, and also gave us a common statement as open access or common property about the fish. I extendly thank you, sir, for giving us such an information. Thank you so much, sir. I extend my sincere gratitude to our principal, Dr. Uma V. Nerle, to organizing this event. Thank you, ma'am. I also thank all the faculties as well as the invitees who have attended and graced the function. Thank you. Finally, I also thank all my student friends. Thank you one and all.
Thank you. Bye.
Thank you.
So we are requesting all the participants to please fill the feedback form. We have shared its link in the chat box. Rohini ma'am, just stop YouTube live streaming.
Okay, ma'am.